Hi guys, let's talk about the cathedral in Manizales. The earthquake in 2026 also damaged this cathedral. We talked about 5 similar buildings in my previous video, but this one is more exceptional. Here we can see the shaking. It's just the left spire, the left tower that shakes. The right side stays still, and this is the moment where it lost its stability and just falls over. So first the shaking once again, where when I stop the video for a second, we see already a weak spot here. This shouldn't be a weak spot because this is a part that's working now, but shouldn't be doing anything. So the question that we're going to solve in this video is why the left one collapsed and the right one didn't even move. So here we see the aftermath. There was a terrace on this floor, and here we see the tower that fell over. We already see some reinforcement that they put there before. We'll come back to this later. And here was a bridge to walk around the tower. We can also see that later more clearly. So this is the same terrace here, but filmed from the other side, just around the corner. And this is that construction that's completely broken that was carrying the bridge. Small lookout. Here on the right side we see the other tower, the tower that had no damage at all. Just like this video shows us, the two towers change into one collapsed one. The right one is still intact. Here we see that bridge that goes around this tower to have a lookout over the Plaza Bolívar. So this is a picture before the collapse, but I would like to show you what happened with the left tower. So the left tower rotated in the direction of the higher tower, so to the right on this picture. And good to mention as well is that there are 4 towers on the corners and one large one in the middle. This is the one that collapsed in 2026. This one is a one renewed. So this one collapsed in an earthquake like 50 years ago, and they renewed that also with more modern materials, so with concrete and reinforcement. The ones on the backside, on the corners, they never collapsed, but they went through earthquakes as well, of course, but they always remained standing. So here we're on Plaza Bolívar. The right tower once collapsed before, the left one fell recently, now in 2026. And these towers here in the back, they were never repaired before. And the main reason for that is the street level. So we see that the tower here starts on about 6 meters. So that would be around 20 feet. So now we're on the other side. And so this is the street level of the corners in the back. So let's say it's almost double the height already. And if we go to this section, we see that there is also a basement in this corner. So we see that also on this view here, the side view. So the collapsed column, the collapsed spire is on this side. The ones that never collapsed here on the left side. And this is street level from the one on the left side. And this is street level from the of the towers on the right side. Plus there's an extra deep basement on this side. So there's a really big difference in height. The taller the tower, the more impact it has to deal with. So here I found a picture of the cathedral in 1941. Here the stone version of the cathedral was recently built. Cathedral existed already before, but in wood, and there was a huge fire, so they had to rebuild it. And they didn't make the same mistake, so they looked for a more fireproof version. And here we see a picture in 1962. This was after the earthquake in 1962, so the same year. And we see that the right tower here is missing. This one collapsed in that earthquake and fell partially on the roof, but mostly here on the ground. The left one remained standing, but there was some severe damage. For example, this crack that we see here, this one was not from this earthquake, but the earthquake 50 years ago. You can also see that in Google Maps here. This crack, they tried to repair it, and we see here damage. This bridge construction is not properly connected anymore to this wall. We see cracks here. Here a picture some days before the collapse. We see also that this bridge has some cracks already. They tried to reinforce this tower. We can also see some cracks here in the facade. Here more cracks. So here as well. This arc also broke already before the earthquake. So we know that this one survived the earthquake in 1962. So they repaired the cracks a bit. They added some reinforcement that Of course, doesn't really help for earthquakes, just for some falling debris maybe, but not much more than that. So they really trusted this tower to deal with a new earthquake. We saw that the movement goes mostly from left to right on this view, and also the tower falls to the right. What we said already before, this is the site where the street is on a lower level, but if we take a look at this top view, for example, we can also say that the building can deal with more loads in this long direction. This is the strong direction for the building, and this is the weak direction. And the loads always look for the weaker spots in the building, so that's why we also saw the shaking going from left to right. We zoom a bit more into this floor plan, because here we see the construction of the cathedral. So this is the entrance with the stairs in the front, and these are the locations of these towers. Here in the front, and here as well. But we also see dashed lines on this drawing, and these dashed lines are the structural parts of the building. So dashed lines are the structural arcs. They really carry the load from the floors on top. So there are these ones. So if we talk about the tower that collapsed, that was here located, and there were two arcs to carry the ceiling. If we take a look on a picture from within the church, this one is made from the altar backwards. So stairs are on this side. This is the side of the collapse, but on this side we see the construction a bit better. So here we see these arcs, the arcs that are more diagonal, they carry the ceiling and they really carry the floor. So they carry floors, this one as well, and this. But then on the other side is carrying the tower. We see here 1, 2 closer to each other, and then a bigger dimension, the next one, the one that carries the tower. And so that's here as well. The smaller ones are the arcs closer to each other, and then this next one. So the tower should be located on top of this arc. And here I added the tower in the software, just to have a bit of an overview of the construction. So here this construction, there are also arcs here in between, just to carry the floor. So diagonal, like we see here. And here this little bridge that was doing all the work. We saw it suffering, but it couldn't hold it. A small detail is that this one has 2 extra openings on this level. So this is then the level of the terrace. I just added a load here to see what the tower does. Then we go to the reactions in the foundation, where we can clearly see that there is some compression here. So arrows upwards are compression, but these kind of constructions also have to deal, and especially in an earthquake, with tension. And since we know that the tower on the right side was renovated with steel and concrete, also means that the tower on the right side can also deal with tension. And the left tower couldn't, because it was not repaired. The only way it could deal with tension was with its own weight, but apparently the weight was not enough because it fell over. Here we also see this bridge part. There were huge forces going from the tower into the bridge and into that wall. We could see the dust flying off. This connection was of course not strong enough and was not made to carry this tower in an earthquake. But what should have dealt with these tension loads are connections in the foundation. For example, they didn't have this at the time, but bolts in the foundation can deal with tension. Now I would like to show you the following video. So recently one guy went into the cathedral to check the aftermath. Actually the area right underneath the tower that collapsed. So we see the debris here on the floor. We see also a hole in the ceiling. For a second we could see it already, but we see the structural arc here, and here we see the bottom of the tower. So the tower actually slipped next to the structural part. Important to mention is that we don't see any connection from that wall of the tower with the structural arc. So that means that they were just cold on top of each other. And we were just talking about tension. If there's no connection, no shear forces or tension forces can be dealt with. So what we said before, hey, the construction need to deal with the tension. We see now that there is a layer in between that cannot even deal with tension. So this tower is just cold on top of this construction. Okay, let's take a look at this model. We see the spire here. Again, just the top part now. So I left the arc construction out because we know that there's tension in these connections here, and these connections cannot transfer from the tower towards the arcs because it's loose. And what we saw is that this bridge was dealing with horizontal forces. I calculated the construction already, so we can see what it does. You have to imagine that there's this arc beam underneath the tower on both sides. So this is the movement what the tower made. So we see that the rotates around this bridge part. So there's a force going from left to right, or right to left, which makes this tower rotate around the bridge. And there's even torsion because the bridge has not the same width as the tower. Now that there are beams here and a beam here, this tower rotates around this bridge till a certain level, because as we can see also at the moment of the collapse, this bridge gave way as well. So the tower came next to the arc beams and fell into this hole actually. So that's what we can see here. And yeah, it fell over and crushed this bridge. So that's what we saw here. The view from this side here, this is that bridge that gave way, including all the columns. It couldn't deal with the tower, of course, and it was not made for that. So yes, the left tower was already a bit weaker because this one had extra windows, but that's a small detail. What made more sense was that this tower never went through a renovation, while the other tower did. This tower could not deal with tension. The loads out of the earthquake were just too high. Alright, I hope you liked the video. Feel free to share your thoughts and see you in the next one again.